you'll be able to see the matrix. Okay. So this is a kind of a thing. This is the whole field they have shown, and you can check that whatever the matrix be shown in the command window, it has come in workspace. So workspace is shown in big, and this is a 3x3 matrix, what you can see here. So Matlab full form is matrix library. Everything has to be done in the form of Matlab. So in this B top, just there is a cross sign, cross it. So it goes. If you want to see A matrix, double click on the A matrix, and it will take some time, and it will come like this. Okay. So this is the A matrix. You can see in the workspace dimension of A matrix and all. Sometimes there comes a dimension mismatch while we are trying to add or subtract or something. That time you should check the variable length, width, row and column, and then you should proceed. So cross again you have come back to the command prompt. Are you with me? All of you, are you with me? Okay, Amruta, Abhishek, fine. So far what we have done is we have done three things. Number one is we have got A matrix 2x2. So in your write-up also you have to just do like this. So name of the experiment will be experiment number 1, basic Matlab commands. So write it down. This is basic Matlab commands. So whatever I do today here in hours, plus some more commands I would send in your group. You have to execute them and you have to write in your journal. So there will be around 40-50 commands in total. So just keep on writing flat the way we are doing it and complete the journal, submit as soon as possible. Okay, so first was 2x2 matrix, second was 3x3 matrix, and next was third work. What we have done is checking the variable in workspace. So first one is 2x2 matrix, second one is 3x3 matrix, third one is check the variable in workspace, like this. Okay. Now I want to clear the workspace and I want to clear the command prompt. So if you are having pen and paper, write down, use the command CLC. I have written CLC. CLC clears the command prompt. So just write CLC and enter. Okay. What you find is the command prompt is cleared. Okay. But then also if you want to check what is the A variable is still there in the workspace, A variable is still there in the memory, B variable is still there in the memory. Okay, so just write A, enter, A is coming. Just write B, B is coming. So you want to check what is the CLC command, so just write CLC, A and B, everything goes. So whatever is there in the command prompt, if you want to clear that, you have to use the command as CLC. So this is going to be your fourth command. So now I'm bringing A and B in the picture like this. Okay. Now what I want to do is I want to clear the workspace and I want to clear the command prompt. So just next command is clear all. Okay, so clear all, and below it is showing there are different kinds of things. By using clear you can do a lot of things. So if you're doing clear all, then what happens? So there is going to be a fifth command, clear all. So enter. See that the workspace has got cleared. Okay, check here, check in the left side, whatever variable was stored in the workspace, that got cleared. Okay, now if you are typing A, nothing comes. Okay, unrecognized variable, because we have cleared the memory here. Okay, so without clearing the workspace, if you are giving A, B, as long as A or B, as long as you are trying to fetch that data again you will be able to fetch it. But after clearing the workspace, the command for that is clear all. Then if you are trying to fetch A or B, it will not happen. Okay, so now clear the workspace as well. You have clear the command prompt as well. Okay. So far we have done 5 things: 2 by 2, 3 by 3. Check variable in the workspace, CLC, and clear all. Okay. Now let us create another variable. So A is equal to, like this. I've created a variable 2 by 2. Not necessary you have to create the same variable. You can create any 2 by 2 matrix, no problem. Okay. And B is equal to semicolon 1 and 8, like this. Okay. Now you can see in the workspace also the same thing has come, that A matrix and B matrix, like this. Now we want to add this to matrix. We want to add this to matrix. So what you do is define another variable as S. Okay. Don't write add. Add is a maybe a function. Okay, so the name of the functions, that is add, subtract, sub, mul, div, don't use those things as a variable names. Okay. You can name the variable as S. Okay. So S is equal to A plus B, and then enter. Just check what you are getting. Okay, and just see whether it is addition of these things. So 3 plus 4 is equal to 7. 5 plus minus 3 is equal to 2. Minus 9 plus 1 is equal to minus 8. And 0 plus 8 is equal to 8. So this is what you are finding is the addition of A and B matrix. Okay. Same way you can do subtract. So another matrix you can take as df, another variable you can say as df. So df is equal to A minus B. If you do that, let's check what you're getting. So A minus B, this is called as point by point subtraction. So A row 1 column 1 3, B row 1 column 1 is 4, so 3 minus 4 is minus 1. A first row second column is 5, and B first row second column is minus 3. So 5 minus of minus 3, 8. A matrix second row first column minus 9, B matrix second row second column second row first column minus 1, so minus 9 minus 1 minus 10, and second row second column 0 minus 8, that will be minus 8. So what we have got is df. Okay, so df is nothing but the subtraction of A and B. So this is A minus B, like this. Okay. Now what I want is, if you want to check what is the subtraction, you can check in the workspace what is there. So whatever is the df matrix, that will load here. Okay. So if you just want to check, sometime now the variables are very small, 2 by 2, 3 by 3. Sometimes the variable may be 70 by 70. In that case, you want to check all the elements of the variable separately. In that case, this workspace will come handy. Okay. All are with me now? Just say yes. I can go forward. Fine, Abrar. Thank you. So I guess I'm not going very fast. These are some very okay. Thank you. Few students have written. Shrishti, Shreyas, Kamal. Thank you. Okay. So these are very simple things, and I had told you on Sunday how to carry out that Matlab on ramp. So Matlab on ramp also will go in the same pace. If you want, we can have a special session. I will be solving. You are also with me. You also will be able to get it forward. So please start doing that. It is very simple, and in the left side in Matlab on ramp, you will be finding they are giving a hint how to proceed and all. Okay. Now I don't want this S to be here. I want to remove. So next point, number 8. Write down clearing one variable from workspace. Previously we had used the command as clear all. Now I want to clear one variable called as s. So what you can is just say clear s. Just say clear s, just see what happens. Now check this workspace, the s variable is gone. Okay, s variable is gone. So I had given clear s variable is gone. Okay. If you want to clear b, so give the command as clear b. It executes and b variable is gone. A and df. So you are having only two variables, a and df. So now do CLC. So first you give clear s, s is gone from the workspace. Then you do clear b, b is gone from the workspace. Now we are having only two variables, a. So bring it in command prompt again, a df. So these are the 2 by 2 matrix we are having with us. Okay. What we'll do now is we will do multiplication. Okay. Now you can give mul1, then multiplication 1 is equal to a star b. Okay, a star b or b nahi df, because df is our variable. Whatever that matrix is defined already, we can get that. Mul1, that is the first multiplication. That means you are multiplying a and df, and after you are multiplying, just check whether it is correct or not. So this is 3 into minus 1, that is minus 3, and 5 into minus 10, that is minus 50. So minus 3 and minus 50 is minus 53. Okay, so a matrix I have defined, df matrix I have defined. Both are 2 by 2, so same row, same column, same dimension matrix you can multiply. I am doing first multiplication. So first row is multiplied with first column, so that is giving minus 53. Then first row is multiplied with second column, that is 24 minus 40, that is minus 16. You have got it. Then this A matrix, second row is multiplied with first column of DF, that is 9, that 9 you are getting. And the second row is multiplied with second column, that is minus 72. So you have got it. Next what you do is B multiplied by A. So mul2, multiplication 2 is equal to B multiplied by A. And you will find that sorry, it cannot be B because B is already gone, so it should be DF. Okay, so mul2 is equal to DF multiplied by A, and the answer will be different. So this is one very important thing we learn in case of matrix, that is forward multiplication and inverse multiplication, they are not same. Okay, so A multiplied by B and B multiplied by A, they are not same. Okay, they are not same. So now again I'll do CLC. So I think you have understood. So what is the next task? Next task is multiplication. In multiplication we are having already two variables. If you can see the workspace, and if you see the command prompt, we are having A matrix, we are having DF matrix, and we are multiplying A into B, and we are multiplying B into A, and they are not same. Okay, so forward and reverse, A into B and B into A, they are not same. So next I'm doing a CLC. I'm clearing the window. Okay. So next I will clear all the spaces. Clear DF I have done. Clear mul1 I have done, and clear mul2 I have done. So I have cleared the workspace. I am having A matrix with me. So A matrix is this. I will define a matrix B. I'll define a matrix B as 1, 2, comma 0, 1. Okay. Now we are entering another important thing. This is something what is required. So we do is define another variable u. Okay, u is equal to a dot star b. Previously we had done only a dot b. Okay, now what we are doing is a dot star b. What is the result? Let us check. Can anybody justify what is it? A dot star b. What result have we got? Can you tell me what is that?
Point-to-point multiplication.
This is called as. This is called as. Very good. Very good. Who is this? Anusha.
Yes, sir.
Okay. Thank you, Anusha. So anybody wants to speak something, please unmute your mic and you can answer. So whenever I am giving a dot, so this is also very important in case of subtraction also this will come, sorry, in case of division also it will come, in case of multiplication also it will come. Okay. So whenever I am putting a dot, this is actually doing point by point multiplication. So it is not a matrix multiplication. It is a what do you call it? So element by element multiplication you can check. So this is the first element 3. This is the second element 1. So exactly the same position, row 1, column 1. So 3 into 1 is equal to 3. Okay. Second, row 2, column 1 and row 2, column 1 for both the matrices. So 5 into 2 is equal to 10. Next is minus 9 into 0, that is 0. And second one is 0 into 1. Okay, that is 0. I have written, so this is after multiplication, now it is point by point multiplication. After that, I have given another function which is called as rank. Okay. Do you know what is the meaning of rank? So I think in your maths you are finding what is the rank. So now I am finding the rank of U matrix. So G I have defined. G is another variable. So whatever operations you are performing, you have to perform first. You have to define a variable, and with respect to that, you have to find that operation. So G, don't only write rank U, but write G is equal to rank U. So you can find here the first row is 3 and 10, and second row everything is 0. Okay, second row everything is 0. Hence there are two rows actually. One row is completely 0. Hence the rank is 1. So this is our next work. That is, we have found what is the rank of a matrix that we have found. Okay. Are you with me till the rank? Are you with me? Yes. Aishwarya, Darshan, Abhishek. So I'm going very slow. Whatever I can do now, so maybe around 20-30 commands I will do, but many more commands I will ask you to do that you can do later on. Okay. So I will do again CLC. I have cleared the command window, and so I'll call A and B, and whatever you're doing for 2 by 2 matrix, the same things are applicable for 3 by 3 matrix as well. Okay, likewise. Now, once you do is x is equal to inverse of A. So inv is a function. Okay, inv is a function you have to remember, or there is enough help. So let us first find how to find the inverse. So this has come the inverse. So it is a little difficult to understand. So let it not be. G is equal to INV of B. This is easier to understand. So how do we find inverse? How do we find inverse? So first what we do is we find the determinant. The determinant, that is 1 into 1 minus 0 into minus 2. So determinant of this thing is 1. Okay. And then all this cofactor, adjoint, and all these things we do. So what is the best way to find the inverse is 1 upon the determinant, 1 upon delta, and change the position of uh, this first row first column and second row second column. So 1 and 1 you have exchanged, it has come there, and first row second column and second row first column, just change the signs. So this is the way we are supposed to inverse the 2 by 2 matrix. So whatever is the position of 1 1 and 2 2, position 1 1 and 2 2, these two elements you exchange, but 1 1 and 2 2 both are same here. So this 1 1 will stay as 1 1. Okay, and outside it is divided by 1 by delta, so delta is equal to 1 for this. So outside 1 by 1, and inside this elements you have to change. You have done that, and other elements, that is 1 2 and 2 1, you have to just change the sign. So whatever G is there, G has become now this is the inverse of matrix B. And one more thing you can check at Workspace. So previously G was the rank of the matrix, and the G was 1. Now as we have used the same variable for defining the inverse of B, see that now G has changed. So G has changed, and now G has become the inverse of matrix. So previously G was 1, it was a one-dimensional matrix. G was the rank of the matrix that we had found previously. But you have used the same variable, okay, and you are finding that in the workspace, the matrix dimension, matrix change, everything has changed. So this is why you should be very careful that you should not use the same variable twice in the same program. Okay, if you're doing that, whenever the element is used later, that value will propagate and previous value will be abolished. Okay, likewise. So G is the inverse of matrix B. Another thing you can do is just do it like this if possible. 1G is equal to inverse of B. Understandable? So 1G is a wrong way of defining variable. Okay, 1G cannot be the name of the variable. Instead, you do G1. If you do G1, or you can do F1. F1 is the inverse of B. Will it happen? Yes, it will happen. Just check that. So you have defined B matrix. You have defined 1G. So what I'm teaching you is how to define variable. How to define a variable. So 1G is not allowed, but G1 is allowed. Likewise. Okay. This is very important. 1F, 1, 2. So it should not start with a number. The defining variable should not start with a number. So CLC I will do again, and I will again call A matrix and B matrix for some further operation. Okay, so there are many operations we can do. Let us see. Okay, likewise. Another way of defining the variable. Let us say I want to add. I want to add A and B. Write add is equal to A plus B. See what happens. Okay. So there's a variable I have given ADD, and they are adding, but it is point by point addition. So 3 plus 1 is equal to 4, 5 plus 2 is equal to 7, minus 9 plus 0 is equal to minus 9, and 0 and 1 is equal to 1. So this is a point by point addition. Likewise. Okay. So how to define variable? Now what you do is add underscore 1. Whether this is allowed or not, A plus B. Add underscore 1. Yes, it is also allowed. So how to define variable? There are many cases. Add underscore one, all these are allowed. Okay. So how to define variable? Because whenever you will be writing big codes, there will be in one code there might be around 70, 80, 100 variables. So you can name the variable as A1, A2, A3, A4, likewise, or you can give AA, AB, AC, AD. Okay, likewise, or ADD1, ADD2, and all. ADD1 also will do. But if I give add gap1 is equal to A plus B, okay, see that it is not going to take. It will not take. So there gap is not allowed. Underscore is allowed, okay, but gap is not allowed while defining a variable. Add and one, the gap, it is not allowed. So all these things you have to mention while you are writing the journal, that what all things are allowed and what all things are not allowed. So G1, G2, G3, G4 allowed, add sub allowed, add underscore one allowed, okay, but one G, one add not allowed. Okay, add gap one not allowed. Okay, likewise. So when I have done CLC, I will do clear all as well. Okay. So I will clear all the workspace and I'll clear all the command prompt likewise. Okay. So these are some very basic understanding that we can do in case of Matlab. Now let us write one word format long. Okay. Long. And do 13 by 7. You will be finding huge. So after decimal 1, 2, 3, 4, 5, 6, 7, 8, 19, 11, 15. So after decimal, there are 15 points which are coming. Okay, those who have got this format long, please write yes. Those who have got this format long, please write yes in the chat box. So format long is nothing but very, you want very high precision. Okay, you have got format long likewise. Now see what is the problem of format long. Now what you do is define a is equal to 2, 3, 4, 6 likewise. Okay, a is equal to 2, 3, 4, 6. So format long, once you have defined, the whole command will go in format long mode only. Okay, now invert this. So b is equal to inb of a. Inb is another function we have seen. There is an inverse. Okay, it is not taking. So this is another knowledge for us, that is 2, 3 and 4, 6, and I am doing inverse. What it is saying is matrix is singular. This is a very special case, remember this. So just like that, I have not taken this matrix, I have taken this matrix to show you something. Can anybody explain what's happening? Delta is equal to 0 here, you can find. Determinant is equal to 0. How to find determinant? Yeah. Is it audible, all of you? Is it audible? Just write Y in the box. Okay, very good, thank you. So what is the problem now is, the problem now is the delta has become 6 into 2 minus 3 into 4. So delta has become 0. Okay, so this is a singular matrix. So what is meant by singular matrix? This is very important. Singular matrix is somewhat where the delta is equal to 0. So we cannot find the inverse of that. So B matrix is the inverse of A, and B matrix is coming to be infinite, infinite, because whatever is the adjoint, cofactor, and all those things. As delta is coming to be 0, all the elements in the inverted matrix is equal to infinite. So what we have to do is let it be CLC, let it be format long only, but we have to take a different kind of matrix. Okay, so now see that here A matrix is workspace, A matrix is 2 3 4 6, what is there, but now I'm defining a different A matrix. So A matrix is 2 minus 5 semicolon 1 and 9 likewise. Okay, now what you do is B is equal to inverse of A. Now see the problem with format long. Okay. So everything that you are finding will come as very big, that is after decimal there are coming 15 points. So this is the problem. So what I did was, you can take any matrix as long as it is not singular. Singular means matrix determinant is equal to 0. It should not be a singular matrix. It should be A is equal to, I'm sorry. Okay. So I have defined any matrix, and what I'm finding is A is equal to 2 minus 5 1 9. This is the way I have defined the matrix. B is equal to invert of A. So B has come like this, very big. Why? This is happening because of format long. Why do you want format long? Format long you want so that you want high precision. Sometimes you want very highly accurate data. Too much precision after in that case we are doing the format long thing. Format bank and then do 13 by 7. Okay, say this. So below, two commands I have shown. One is format bank, another is format long. So can anybody, so same thing, 13 by 7, same thing I have done. Format bank I have done, and format long I have done. So can anybody explain what is the difference, format bank and format long? Anybody please unmute your mic and just tell. Yes, who is this?
Mohit sir. Format
Mohit, yep.
approximates the decimal value we have.
Yeah, so format bank approximates it up to how many values?
2.
2 values. So format long you are finding it is 1.8571 something, so 1.857. So third digit is 7, hence it is greater than 5, so it will become 1.86. Okay, so this is something, format bank, format long. There is something else, which is called as format short, and then again do the same thing, 13 by 7. Just see what is the answer. So these are the 3 things you remember: format long, format bank, format short. Can anybody explain all these 3? What is meant by format long, what is format bank, and what is format short? Any one of you, please unmute your mic and explain. So format bank 13 by 7, format long 13 by 7, format short 13 by 7. What are the differences? Anybody who is there? Amruta, can you explain? Can anybody explain these 3 things together?
Sir, can I?
Yes, sure.
Sir, in format lang, it will show all decimal points, sir.
All
After
means how
decimal,
many?
it will show up to 10 decimal points, sir.
10,
After
15.
point
You just count it.
15. Yes, sir. 15. 1, 2,
Yep.
3.
Then
Yes, sir. Then format bank, sir. it will show 2 decimal points, sir.
Correct.
For format chart, it show 4 decimal points.
It show 4 decimal point. Thank you. What's your name? KIR.
Kiran,
Okay. So your surname is there, G. So Ajay, so this is what we are supposed to understand. That is, you can see 1.85714. So 714 means 4 is less than 5. So it is truncated up to 1.8571. See, exactly this kind of thing happens inside the microprocessor. Whenever you are processing some data, up to which decimal point you have to consider, and after which decimal point you have to approximate, this decides what is going to be the precision of your data. See, this format long, format bank, format short, this is doing what? This is actually giving you different uh, level of precision, okay, that you want to incorporate, that you want to get your data format in. So different amount of precision you want, you are going to use different kind of commands. So when you want too much of precision, format long, you first define format long and then you do all the calculations. You want smallest space to be occupied in the memory. In that case, you use format bank. And moderate, so format short. So when nothing is mentioned in the Matlab, generally it is taking format short as the by default kind of a setting. So now I'll do is CLC. Okay, all the things are gone. So far as my list is concerned, I have got around 17 different activities that we have done. Okay, so A matrix is there. We are going for the next. Can I go for the next? Format long, format short, format bank. It is understood. So can I go for the next? Okay, Aishwarya is saying yes. So next is transpose. Okay, so S is equal to A transpose. So A, and top side you have to give a that just left side of the enter, there is a button you see in your laptop or computer. So A dash, S is equal to A dash. If you are doing now, this is going to give you transpose. Okay, S is equal to A dash. So that way you are getting as transpose. Next is date. You just write down what is date today. So just write down what is date, and we'll show you what is the date for today. Now somebody wants to get the time. In that case, you have to type time. Okay, so date time. Okay, so time ऐसा नहीं आता है. How to get the time? Okay, so date I think you have got. So CLC 20 April this thing. So A matrix is this, and 13 by 7 is this. Okay, like this. So I have got two things. These are two inputs we'll be playing with. So A is equal to some matrix, and 13 by 7 is 1.8571. Do one thing, define another variable. So date is another thing that you have got. That is another function. Time we could not get, but time also can be got. I will show you what is the function for that. Now do something else. D is equal to absolute of A. Just see this format. D is equal to ABS. ABS is a function, and A is again I have made a mistake. So D is equal to absolute of okay. So do CLC. Do CLC. Just wait. Give me some time. F is equal to 13 by 7, and D is equal to absolute of F. This you do.
sir, I have one doubt, sir.
Hello?
Yes, sir. Sir, doubt, sir.
Yep. Ask.
Hello, sir.
Yes, ask.
So if I didn't give any format, sir, like a format short, format long, format back, sir,
Correct.
then what will be the answer, sir, when I do division, sir?
Whenever you don't ask me, you just log into MATLAB for the first time, and you just do 13 by 7, and you will
Okay.
check what value it is giving. Mostly it gives 4 point.
Okay.
Okay. You whenever
Okay.
just after you are logging in, you just do what the value it is giving. Okay. So there, mostly it is giving whatever value it is giving you up to 4 point. Okay.
Sir,
So let us, yes, yes. What?
so once we give this format short, format bank, we can't go back to the default value. We don't
Again
get
you have to write it. Okay, so I'll show you that. Now it is this value. Then format long if you are doing, then F. Okay, it has come like this. So initially I have done F is equal to 13 by 7. It has come 1.8571. Then format long is like this. Now anything you do 56 by 3, it will come in format long only. Okay. So once you have written format long, that format long command will stay in the memory of the MATLAB from wherever it is getting executed. So whatever value you are executing, it will be in the format long only. Now you change it, format bank, and now you do 56 by 3. Understandable? So now if you want to go
yes, sir.
back, just give it to format short. So format short is the easiest way or most understandable way for us to do 56 by 3. Will be giving you up to 4 decimal. So it's a good question you have asked. That is how to change the accuracy level. So generally nothing is mentioned. Default it will take up to 4 decimal point. Okay. And after that, if you want to change to high precision, you have to give format long command. If you want to get a smaller value of precision, you have to give format bank, and then you can come back always to 4 decimal point, which is more okay kind of a thing. In that case, you have to give format short. Understandable? The format short command means you are coming back to normalcy. So format short is the most normal kind of representation. That is 4 decimal after this thing. 4 decimal after after this thing. Okay. So just take a break for around 2-3 minutes. I'm shutting my screen, and again we'll come back and we'll be seeing some more functions. Okay. So just take a break for around 3-4 minutes and come back as soon as possible. Okay, welcome back. So let us take some more commands than what we have seen. So let us go into the domain of uh, absolute value. Are you all there? Okay, somebody has asked to upload the recorded video. So video is generally available in the same link from wherever you are logged in. Okay, so madam is there. I will ask madam. Mostly you will be finding in your Google Classroom, which is for the whole division, which is for the whole class. That is ABCD division. Wherever it is there, there you will find the whole video. Okay, many people have left. That is not right. So let everybody join. Okay, so let us do some more commands. So clear all. So what is the last command we did? What
Absolute.
was the last comment we did? Yes. Anybody? You can write it in the chat box.
Finding absolute values.
Finding absolute value, but that did not come. Okay, so define one. A is equal to 2 plus J star 7. So first you have to clear all CLC. First what you do is clear all and CLC. That will clear your workspace. That will clear your command window. And then you define a new vector A is equal to 2 plus J7. Now you can find out absolute value. So D is equal to absolute of A. Okay. Now it will give you the absolute value. So two things you have learned from here. What are the two things? First thing is how to define a complex number. That is whatever J is there, that J is to be defined properly in the complex domain. So A is equal to 2 plus Ji, J7. So if you're writing that, it comes like this: 2 plus 7 I or something. And then we are doing D is equal to ABS of A. So ABS is a function which is helping us to understand what it is. Now somebody try to find, so D is equal to cos of 30 degree. Is the value right? But D is equal to cos of 90. First we do. Okay, so what is the problem? 0.4431. CLC D is equal to cos of pi. Now you are getting it right. Okay, that means whatever value you are entering in cos, so that has to be in the domain of pi. Okay, radian. Cos of pi radian, okay, is equal to so D is equal to, again you can do D is equal to cos of pi by 6. Pi is given by pi pi, okay, pi by 6. Now you are getting the value 0.866. So 0.866 is nothing but root 3 by 2. So be careful while you are entering the value in angle. Okay. So angle should be in radian. Okay. And another thing you have found out, that is what is the use of pi. Okay, so pi, you can just write on pi, okay, and the value will return as 3.1416. Again, you can do the format, short format, long for this, and you will be finding what is the short value or long value of pi. So pi is another thing you have come to know. So sine also you can do, yes, sine of pi by 2. So pi by 2 is 90, so sine pi by 2 should be 1. It has come as 1. Okay. Now you can do cos of pi by 2. So cos of pi by 2 has come to be very small. So something raised to minus 17 e raised to minus 17. That means something is 0. So cos of pi by 2 is 0. So sine, cos, all those things you have come to know. Likewise, you can do tan, cot, cosec, and all those things. All those things. Just check whether you can do that, find that or not. Okay, so CLC I'm doing. Okay, so I'm clearing the screen. So internet is slow, it has got stuck. So I've gone back and again coming back. Sorry. So after login, you will come back to this main page, and there you can click on Matlab Online, and you'll be directed to this command prompt. Likewise. So D is equal to cos of pi by 6. This is giving you 0.866. Now you want to find inverse. Okay. How to find inverse? Just let me give a try. DF is equal to A cos 0.866. Okay. So does it come to be pi by 6? What is pi? So value of pi is 3.14 divided by pi by 6. So it is correct. Is it understandable what I'm doing? So D is equal to cos pi by 6. So cos pi by 6 is equal to 0.52. So pi is 0.5233. So you can do like this. GG is equal to cos of pi by 6. So instead of pi by 6, you write down 0.5233 like this, and you are getting answer as 0.8662. And then you do A cos. So A cos is something which is called as inverse. Okay. Same thing you can do for tan. Okay. So y is equal to tan of 90. 90 is pi by 2. Now how much is pi by 2? 3.14 divided by 2. So you can write pi by 2 as well, or you can write 1.57. 1.57 is nothing but pi by 2. So the answer should be like this. Tan pi by 2 is very small. Okay, 0. So almost 0. Now you want to find inverse. How to find inverse? So you can give number as inverse y. Okay. Inverse y is equal to A tan. So A tan is the command for inverse. So now you can select here. You can select this, copy, and you can paste here like this. And then it should return you the value of pi by 2 or 1.57. Just check. It is 1.57. Okay. So forward and inverse, A cos, A sine, A tan, all these things are the inverse thing. So that you have been told. likewise. So there is a list that we had prepared last day, last year actually. So here you can, I think, see the list, that is cosine, sine, tangent, arc cosine, arc cosine. So a cos, a sine, a tan, likewise. So all these are actually the inverse. Okay, now coming some other thing, exponential, square root, and log base 10. Okay, let us see. So again, you do CLC, clear all, likewise. Okay. So are you guys with me? I'm finding 46 people. You are able to hear it properly, right? Just say yes or no in the group, in the chat. Fine. Am I going very fast or something? This pace is okay? Kiran, fine. Thank you. Thanks, guys. That's all. Okay. So what we do is we define something. So a is equal to let's say 36. Okay, and b is equal to square root of a. So whenever you are typing some value, this should be within the matrix of round matrix. So likewise. Okay. So next is coming square root, and d is equal to s cube of b if we do. So it is not coming. So how to write square? So b is equal to, I want to do the square. Square of a, let's say. So a raised to 2. So this is how square or any power is done. So we know a is equal to, so sq is not the proper function, I'm sorry, but square is given by a square. Okay, so a is given as 36 and b will be square of a, that is 36 square, that is 1296. You can write a into a, that is one thing, or you can write a raised to 3, likewise. Or you can say g is equal to square root sqrt of, so now the value of b has changed. You'll be finding gg is giving us 36. So sqrt is another function, and how to write the power raised to something, that I have shown you. Okay. So d is equal to 6, s is equal to d raised to, so raised to you will find in the number wherever is there. So number 6 is there in the keyboard. If you do the shift and press the number 6 button, you will be getting that. You can do s is equal to d raised to 3. So you are finding 6 raised to 3 is equal to 216. Okay. This is there. Again, another thing we do, sd is equal to log of s. So log is another command or function that we are understanding. Okay. Log of s equal to, sdg is just a function name, log of 10, and this is the same thing we s that we had got previously. So the values are different. What is log and what is log base 10? Okay. So these are different things. So ty is equal to log e. Do we have a log e? No. Okay. So what is the difference? Log means natural log. So whatever you are finding here, SD, okay, this is actually natural log. That means this is base e. And generally whatever log we do is log 10. Okay, so that log 10 is having function as log 10. And so log is natural log e, and log 10 is, so log 10 and log. So log means natural log and log 10 is base 10. Likewise. So again, I'm doing CLC. I'll go back to the list and I'll find out what all can be done. Give another try. So A is equal to uh, just define another array now. Okay. So after this log and all, I'm going for A is equal to define an array 2, 3, 5, minus 1, 4, 0, 89, like this. So this is an array I have defined. Now what I'm doing is, so this array is defined. If you don't want to display this array, then what to do? So now I'm telling you the function of semicolon. Okay. So if you don't want to display the array, then put a semicolon and enter. So just see the difference between these 4-5 lines which are displayed. First line A is equal to 235 minus 14089, and I have not put a semicolon here. Then if I press a enter, then the whole array is displayed like this. Okay. But next line I have executed the same thing, but I have put a semicolon here. Okay. So if I'm putting a semicolon, in that case the whole value, whole matrix will go into A. So A is displayed here, you can see in the workspace, but it will not be displayed in the command prompt. Okay. So the value is stored in the workspace only. Okay. Now what I'll do is max of A. What is the maximum element? So you can give name as max A is equal to max of A. So this maxa, this is actually the name of the variable. You can give any name. You can give any name. You can give Y, MY, anything, or you can give name as P. P is equal to max of A. So whatever is the maximum element in the array, that will be displayed by P. Okay. So P is equal to max A, and Q is equal to min A. Just check. So here it is -1. So max and min can be found out like this. Whatever is the max and whatever is the mean. Now what are the other things which are there in the list? Okay, max means seal, floor, round, rem. So again, CLC. Is max main understood? So define any variable with an array, and then suppose A is equal to a array. In that case, you want to find what is the max element in the array. Okay, so in that case, you have to just do max of A, and it will return you the value with the maximum value. Now what I'll do is, suppose I will do A is equal to 13 by 7 or 22 by 7. Let's do pi, or let's say only pi. A is equal to pi. Okay, like this. S is equal to sil A. Now these are 4 commands which are coming, very important. So first is seal, C-I-L. Seal comes from sealing. Okay. So I know A matrix, sorry, A is the value 3.1416. Seal means just exactly next integer, whatever is the value, it will be shown. Okay, so round toward plus infinity. Then what you do is, if G is equal to floor, floor of A. Just check what is the value. Floor means just below. So 3.1416. We are playing with this number. 3.1416. Just the above integer, that is towards ceiling. That is 4. Okay, so that will be sill of A. Okay. And floor of A. Floor of A is just below integer, whatever is there. That is 3. So sill and floor is done. Next is round and rem. Okay, round and rem. So just do that. ET is equal to round of A. What is giving? It is giving 3. So 3.1416 is 3. Difference between floor and round. Now there is a question. So first is seal, then there is floor, and then there is round. So in this case, both, so seal is understand higher order integer, floor is lower integer. Round of A. So what is round? So again I will do CLC. I'll define one value. D is equal to 3.78 and K is equal to round of D. Now you will find the difference. And M is equal to seal of D. Sorry, floor of D. Can anybody explain what is the difference between round and floor? What is the difference between round and floor?
Round will round off the value to the next big number. Float
Sure.
will take it back to the previous one.
Yeah, Aishwarya, speak.
3.7 after points it is greater than 5, then it become
0.5. Greater than 0.5. So it will become 4.
yes sir.
Correct.
Then floor means exact that before 0.3.
Yeah, floor actually, floor and sill, they will actually take it to the integer. Floor will take it to the lower integer, sill will take it to the higher integer. Okay, but whatever other command we are using, what is that? That is round. Round is exactly the approximation that we do. Okay, so if it is 3.27, let's say R is equal to 3.27, and then you do define another thing which is round R. Then it will take it to the. Okay, so if the in shortcut I can tell you, if the value of the whatever thing is there variable, it is above 0.5, then round off will be equal to seal, as you have found in case of the previous case. Like the value of this thing is 3.78. In that case, it will round to the seal value. That means it will round it to the 4. But if it is 3.27, in that case, it will round to the lower value, to the floor value, that is 3. So 3.27, if it is the actual value of the variable, then round and floor, they are same. If the value of the element is above 0.5, here 3.78, in that case, round will be same as seal. Okay, likewise. Now all these things we have to do for a negative thing. So we do CLC to define. So you can do it clear all as well as. So seal round floor clear all. A is equal to minus 3.27 and B is equal to seal of A. What will it be? Understandable? So as I have done taken negative thing, in that case minus 3.27, it will go to the higher integer and floor will give you minus 4. So C is equal to floor of A. This is giving you minus 4. and round of A. So as this is in between 3 and 3.27, 3.5, so it will round to -3. Okay. So this is a very important concept. Seal and floor. Seal is sealing. Sometimes what will happen is after you are doing some operation, maybe it's a very big table, maybe some 70 by 70 elements are there, and you want to round off, or you want to round off all the elements in that. You don't want decimal, because why not? Because you will be studying this microprocessor or microcontroller architecture now. So there is memory. If it is 3.27, that means you have to save 3, you have to save decimal, you have to save 2, you have to save 7. All these 4 things is taking a lot of memory space. Instead of, what you will do is you will round it off and only save one integer. Okay, so there will be little error in the result, correct, but it will be approximated, and with a lot less memory space you can save the data. So that is the main reason we are using this round and other thing. Is it okay? Can I go for the next one? So not only what to do, but what is the significance. The significance also you have to understand. Okay. So significance of round is, we want to check whether it will be saved, the same element will be saved in a small amount of position of memory space. So by doing all this seal and round and other things, we are actually trying to save the memory space. That is it. Correct. Let us do remainder. What is the remainder? So I'll do CLC. SS is equal to pi. Okay, what is the value? Then DF is equal to remainder of SS. Okay. Not enough input argument. What is the remainder it is saying? Remainder after division. Error using rem. Whenever this error is coming, just check the Matlab help, what it is giving. Okay, the syntax is R is equal to remainder A comma B. So always go to the help and find what it is. So all these things are very clearly explained in the Matlab on RAM. Okay. So if you go to the Matlab on RAM, it will explain everything. So take A and B and then do remainder. So R is equal to remainder of 4 and 6. So I think there is a comma in between. Just let me check. Yes, there is a comma in between. So let's take 40 and 6. Then I'll give you. So 6 is, you are dividing 40 with 6. So 6 into 6 is 36 and remainder is 4. So this is how the remainder thing occurs. If you want to know about remainder, okay, so in that case just write help remainder. There is a function and it is going to show you everything about remainder. So this is what. So we have done remainder, and I've told you how to use the help command. Okay. So if you're coming here, again CLC go, suppose help remainder and enter. As this is a function, remainder is a function, so this will come in purple color. Okay. And then it will be showing you all the cases. So remainder x comma y returns x minus fix x dot by y and all this thing. So fix is another function you can try. Okay. So if you want, you can just say help fix. What does fix give you? Okay. So if you click on fix, documentation for fix, will be showing you what does fix do. Just check here, fix x. y is equal to fix of x. So x rounds each element x in the nearest integer towards 0. Fix is another thing, it will be doing towards 0. Okay, so now see the fun, what happens. So CLC, so another thing we will see as another function we will see as fix. Define this thing. So d is equal to 13.27. Okay, so just keep writing all these functions. Later on you can try on your own. So g is equal to fix of d. If you are doing, then what happens? It will be giving you 13. Okay. So you can say it is floor. No, it is not floor. Floor and fix, they are different. So it is fix is always taking you towards 0. With the same command, I will define try is equal to minus 2.3 points. So try cannot happen. Whenever it is showing blue, see, this is showing blue now. What is meant by that? In that case, try is a function. You cannot take it as a variable. These are the things you have to understand. So try, you just write down this. Negative minus 2.37. Now this is fix of tryu. Understandable? It is going to minus 2. So here it is behaving like floor. G is equal to fix D. It is giving you the value as 13 because here D you had defined as 13.27. Now if you're trying to fix it, it will be fixing it to the value which is closer to 0. So if you are at 13.27, closer to 0 is 13. Okay. But if you are giving the value as minus 2.37, in that case it is giving you the seal value. It is giving you the value as minus 2. Anybody having doubt in this? In fix? So fix always takes you towards closer to 0. The rounded value which is closer to 0. Seal always takes you the rounded value above. Okay, always if it is 3.27, it will take you to 4. It's 5.78, it will take you to 6. Likewise, floor always takes you to the lower value. Okay. And if you want to check the real function of fix, what you have to do is take a value which is greater than 0, like 13.27. Fix will give you 13. Take another value lower than 0, that is minus 2.37, and if you're fixing that, it will be giving you the value as minus 2. So best example is given here with floor, with fix with a positive value and with a negative value. Okay. So these are some of the elementary functions that we are checking, and there is a full list of it. I will forward this list to you. Then pi, INF, NAN. NAN is not a number. Okay. Complex conjugate and angle, phase angle, rem. So now we will see two more functions. One is angle and one is conjugate. So define A is equal to 2 plus I8. It is not taking anything, right? It will not take. So A is equal to 2 plus I multiplied by 8 you have to do. 2 plus I8 only you do, it will not take. Unrecognized function. So A is equal to 2 plus I8. The first thing you can do is D is equal to absolute of A. That I have already shown you how to find the absolute value. So absolute is nothing but root under of 2 square plus 8 square. So root under of 4 plus 64, that is root under of 68. So root under of 68 is nothing but 8.2462. So this is the absolute value. Now you want to find the angle. So tan inverse y by x. So C is equal to angle of A. Okay. So this is tan inverse of 2 by 8. So inverse of 4. So tan inverse of 4 in radian. So how to do that? tan inverse of 4. Tan inverse of 4 in degree is coming to be 75.96. Okay, tan inverse of 4. So here you are doing angle of A. C is equal to angle of A. Angle of A means angle of 8 by 2. That is imaginary by real. That means C is equal to angle of A means tan inverse 4. So tan inverse 4 is 76 degree. Can anybody confirm how to convert into degree into radian? So very simple thing. 180 degree is equal to pi radian. Radian is given by C. Okay, small c. Or you can say pi radian is equal to 180 degree. 1 radian is equal to 180 degree divided by pi. And now 1.3258 radian into 180 divided by pi. It comes to be 76 degrees. So you just check, so whatever value you have got here, that is 1.3858, 1.3258. This is in radian. And if you convert this thing into degree, it will come as 76 degree. Okay. So how to do it? Pi radian is equal to 180 degree. 1 radian is equal to 180 degree divided by pi. Pi means 3.14. Okay. So 1 radian is equal to 180 divided by pi. So that means around 57.32. So 57.32. So whatever radian value you get, if you multiply that by some factor, okay, so 180 divided by 3.14, that is 57.32. So multiply this 1.3258 with 57.32, you are going to get 76. So whatever radian value you get, you multiply that by 57.32 and you will be getting the degree value. This is the simplest way to understand it. So this is the angle. Now A is given 2 plus ij, and you can say F is equal to conjugate of A. That is complex conjugate. It is giving you, so you can check here. A is equal to 2 plus ij, okay, and F is equal to 2 minus ij. So this is another function. So just now we have checked with respect to some complex number. We have seen the function as angle, conjugate, and absolute. So these are the so there are n number of functions you can do. So these are some of the functions that I have shown. So this is a whole list, okay, which is there. Now let us see some plotting kind of functions. Okay. Let us generate a sinusoidal plot. What you have to do is first you have to define time. So now we are entering in a small program kind of a thing. So first you have to define time. So t is equal to start from 0.1 colon, okay, 0.01 and up to 5. So this is the time scale you have defined. Or you can start from 0 as well, never mind. Okay. And then obviously give a semicolon because you don't want it to be displayed. So this is how you are defined time. Y is equal to sine of t colon, sorry, semicolon, and plot y. It will take some time. Hello. Okay. So those who have got this sinusoidal waveform, please respond in the group. A very small code we have. So let me share. Those who have got all this sinusoidal waveform, please let me know. In the meet, just say yes. So it's a very small 3-line code. First I've defined t time t. Hello, first I've defined time t. Anybody obtained the sinusoidal, please write in the chat box as yes, why. So t is equal to 0. 5 divided by 0.01, that is 500 parts. So that's why the x-axis is showing us 500. Actually it is 5, but it is showing with the resolution. You want to see the whole graph, you want to see the whole graph, you can say 0 to 2 pi. And copy the same thing, that is t is equal to 0 up to 0.01 up to 2 into pi. Semicolon. Y is equal to sine t and plot y. Now the graph will be shown and we'll be giving you the graph for total sinusoidal waveform. So it's taking some time to plot. I'll remove it. Clear all. CLC. So redefine t is equal to 0, 0.1 up to 2 pi. And the same thing. And I don't want to display these values. Then y is equal to sine of t and plot y. So it will give you a complete cycle of sinusoidal waveform because you have plotted it from 0 to 2 pi. Nobody got this sinusoidal waveform? Got it, sir. Now the problem is while you are running the simulation, it is actually calculating all the values. How many values it is calculating? So 0 to 2 pi. 2 pi means around 6.28. So 6.28 is divided by 0.1. That means 628 values it is calculating in the back. Okay. So 628 values it is calculating in the back and then it is displaying. So to calculate 628 values and display, it is taking some time, and it is accessing the cloud to calculate all these things. Because I told you this is, we are taking the software as a service. So this software we are accessing directly from cloud. So everybody asking for the same space and all those things. So in that case, it is taking some time. Okay. So better at night time, you can access this online internet by using your GIT email ID. and you can do all these things. So now another plot we will do, and that will be the last thing for now. You have done time scaling. Okay, so I will show you that time scaling thing. So plot another thing. Y1 is equal to sine of 2t. Okay, and plot y1. So 2t, don't write 2t directly. 2t you have to write 2 into t. Okay, so this is below I am showing. Now another plot I am doing. So this plot you remove first, otherwise it will create some problem. I have defined another variable which is called as y1. Now I am just trying to plot y1. Y1 is a sine of 2t. So time scale is the same, 0 to 2 pi. And instead of plotting sine t, you just plot sine 2t. And just check what you are getting. Okay, so you are finding that the waveform has become squeezed. That means the x-axis has become squeezed. So within the same period of 0 to pi. So time scale is same, 0 to pi, but you have increased the frequency. Okay, you have increased, you can say 2t. Previously you were representing only one cycle between 0 to pi. Now you're representing 2 cycles in between 0 to pi. If I ask you represent 10 cycles, what will happen in that case? This will be y3 is equal to sine of 10t. You can write down. Okay, so this is y3 is equal to sine of 10t, and then plot. So just remove it and then plot y3. Yeah. Now you'll be finding there will come 10 cycles. Likewise, but there is a problem. Does this look like sinusoidal waveform? It does not. Okay, why it does not look like? Because this is called aliasing. Okay, this is actually what is called aliasing. Now you just change this in between time, sampling time. Okay, you reduce the sampling time to 0.001 and plot it, and you will be finding that you are getting perfect sinusoidal waveform. So I'm leaving you here. This is your last task. Write down the job as time is equal to 0.001. So this is the time step 0 to 0.001 up to 2 pi, and then plot whatever you have done, sine of 10t. Okay, so instead of intermediate time as 0.1, make it 0.001. Sampling time very small. If you are doing sampling time very small, means actually you are increasing the sampling frequency. And then plot y3, you'll be finding that this sinusoidal waveform will be very smooth. So whatever you're seeing here now, this is the aliasing effect. You have heard of it, but you did not know how to choose the sample value to get proper anti-aliasing. So I'm leaving you here. I'll be sending a lot of instruction in the group. Please follow and submit the experiment in the main group of all 4 divisions, A, B, C, D. Any doubt also you can post in the group. I will try to answer, or you can mail. That's all from me now. Thank you.